Thank you. Good morning, everybody. I'm happy to be here, but I'm a little bit an outsider, but I'm happy to share and to learn from all of you about shipping. I'm Christelle Not from Earth Science Department at HKU, and I'm a climatologist or paleoceanographer, meaning that I look at how the climate was in the past and how where the ocean current were in the past, for example. And I will focus in the Arctic Ocean is the reason that I'm here, because why we do paleo studies is to really help us to understand what would be the future by looking at evidence from the past. So it's really for us a look at the memory of the Earth or of the ocean to understand what is coming. And today I want to really give you a quick overview of what do we know of an Arctic without ice, because we know that it's where we are going, and what will be then the implication for shipping. So briefly, I think you all know that map, and as I've also mentioned from beginning, so this is the Arctic Ocean. What I want to highlight here, it's a very specific ocean in comparison to all the other world ocean. It's quite closed, meaning that there is only 2 or 3 connection with the other ocean that are in the Bering Sea in the north here, and then here the Canadian archipelago, and here Fram Strait. So it's very, very enclosed with very limited route, even when we talk about shipping. Also, it is very separated here by the Lomonosov Ridge that really cut, and especially when we think about ocean and current, that cut the ocean in 2. And these have consequences also for sea ice and transport and sea ice pattern, and where do we will see the ice or the sea ice. And then an additional point is it's surrounded by continent, but from different countries. And all of those countries have right and are at the table to discuss what is the future of the Arctic. So we need to consider also there is a lot of negotiation between different countries when we talk about the Arctic oceans. An additional point is the land all around the Arctic that is really surrounded is frozen land. It's permafrost. And when we think about climate, these have a huge impact. We know that the Earth is warming and will continue to warm for the coming decades, centuries. That means that this frozen land will unfroze and will also change. So all the infrastructure potentially necessary to some shipping industry have to consider that you are building potential facilities in a very fragile environment. So this is really what I'm doing, and I know it might look a little bit overwhelming as a diagram. These arrows look at the ocean currents from the surface, top surface, which is important for shipping, but further down. And why I'm showing you that diagram is because it's why the Arctic is so important when we think about or we talk about climate is because the Arctic play a key role in controlling the Earth climate. It's not only that the Arctic receive and adjust to the global warming, it's really a key ocean in controlling the climate. Why is that? The different colors in the arrow. The reddish one is warm water that bring heat, and the blue one is the one that bring cold water. So what do you see? It's that added to the limited connection. What you see is the water stay around the Arctic, and there is almost only one way for the ocean water to go out from the Arctic is from Fram Strait. This big connection here. Bering Strait, you have only entry of water because of the water depth here. It's very shallow. And in the Arctic Canadian here, you have a little bit of outside waters, but it's very limited. So most of the water that goes out of the Arctic and almost that goes in come from here. So you have warm water that comes in. That also play a role in decreasing the sea ice. We can go back to that. And then we have cold water or colder water that are becoming less and less cold that gets out. So this is very important when we think about climate. And in fact, this role, if we put back the Arctic with the global Atlantic or global ocean circulation, it's really a place where you have an exchange of a transition from warm to cold water. So anything that we do, the global climate is partially controlled by what happens in the Arctic. On top of that, the other factors that play a critical role on the Earth climate, and you probably all know that, is what we call the albedo. So the presence of ice, of white surface, could be sea ice, it could be land ice, allow the radiation to be sent back into the atmosphere, so it keeps the Earth cooler. Whereas when we have a radiation on the sea with no ice, the radiation are absorbed into the ocean that warm the water. So albedo plus circulation in the Arctic that control heat transport into other oceans are two factors why the Arctic play a crucial role into global climate. However, that, as I mentioned, for the circulation, we know that this is changing because the water is warmer and warmer in the North Atlantic, means bring warmer water in the Arctic, so it doesn't cool down as it used to cool. So in general, the water warms. And in the albedo, we also know that the sea ice, we have seen that earlier today, that we know that the sea ice is declining from year to year. So most of, to look at the sea ice, we look at the summer extent of the sea ice, and we have a decrease. So the yellow line, look at the median extent between 81 to 2010. And if you look at the recent years, all of them are below the gray line. So we are always below that the average of the last 30 years. So definitely this decreasing trend in sea ice is here. It's happening. There is no question about that. An additional factor, okay, it's important to look at where the sea ice is, but it's also very important to see how thick is the ice. And when we look at the different, the age, and Adolf showed that earlier, what we see is obviously the thicker or the older the ice is, the longest it will take to melt. So a 1 year ice will melt seasonally. So the next summer, we have no more sea ice, but as 2 years or 3 years will take more time. But what we see, it's a very a decrease in all, and especially the older ice, so the thicker ice. So we mean that we know we have easier access to the Arctic, just like physically because of the sea ice. Another factor that is important to look at is land ice, and in the Arctic it's relatively limited. This year we have only ice sheet only in the Greenland, but why this ice is important is related to sea level. So the melting of sea ice won't affect the sea level, whereas the melting of ice sheet or land ice have a strong impact on sea level. And when we think again about the Arctic and all the different channels that they can be used, thinking of sea level is critical. If you remember, I said at the moment we have only one big entry exit of the water, and we have at the Bering Sea, for example, it's very shallow. It's 35 meters. So the connection here is quite shallow. It's only one way. Now, if we think about change in sea level, this will change the topography. So what do we know from the past? So this is Earth history. So we are looking at, so here it's 0, and we are going back in time to 100 million years ago. So it's, let's call that in terms of the Earth history, that is approximately 4.5 billion years. It's a quick history of the Earth. And what are the information we have here? You have in gray the gases or estimated CO2 concentration, and you have in colors is the global mean temperature. What I want you to focus on is the blue line here that shows when do we, from the last 100 million years ago, when do we had ice in the South Pole, and in the Arctic Ocean, so North Hemisphere ice, which is the Arctic Ocean. So we had ice in our history only in a few periods of time, meaning that most of the last 100 million years were Antarctic with no ice. It means it's where we are heading. We know that we will go there relatively soon. It will take a couple of decades or maybe a century, even less. And these are the scenarios. So when we do paleoceanography, we want to go back to period of the time of the Earth history where we had conditions that might happen in 20 years or in 50 years. So when you look at that, you say, okay, except the recent past, the last million years or 2 million years, we need to go further back in time to try to understand what were the conditions at that time. So it's what we are trying to do. And again, this is just a snapshot of the last 500,000 years, and it's where we had sea ice. So it's the closest that we have to what we are experiencing today, sea ice with changing ice, with decreasing ice. So how fast it happened, how fast it changed the circulation, how fast it changed the sea level. This is what we want to understand, because we want to be, at least to be able to give answers to climate modelists or people who do activities like shipping. You will need that information. So here, if you look at the last 500,000 years, you see that we had period where it was warmer, where we have ice and then no ice. And the interesting point here is the change in the sea level. So the last time we had a higher sea level than today was 125,000 years ago. And it was a very different connection than with the Pacific at the Berings, because we had like 10 meters more water. So it really influenced the connections. So this is our goal by doing paleoceanography. However, again, we are playing in the Arctic. So what do we do? Just a brief for people who are not familiar with what can we do to look at the past. We look at archive, obviously the basic one in instrumental or historical, but these are very limited in time, only a century. If you want to go back to million years timescale or thousands, as I show you, you need to use ocean sediment core, meaning that we go at the bottom of the ocean, we core those, and this is how we get them. And then start the difficulty. So this is a sediment core, for example, and then we can go back in time. In the Arctic Ocean, we face the difficulties that the shipping is facing today is the presence of sea ice. So this is just to give you an example of sediment core that have been collected by almost, this is only the German expedition. You will see just after there is several other countries who run expedition, but this is the Germans one. And what do you notice? There is places, and in particular, for example, here, where we have almost no sediment core. The reason is the ice. We have the limitation of the presence of thick ice, so we cannot go and get the data. And so these are the different countries that have activities in paleoclimate. So they have icebreakers that do expedition. So it's a couple of countries: Germany, Russia, Sweden, US, Canada, China, and Korea. For most of the time when we want to go in activity with high sea ice, it's expedition that require international collaboration. And this is the only expedition that happened in 2004 that close to the North Pole that did a very long-term record, talking about few million years. And the way they set that, there were one boat here that was coring, so attached to the boat, there were a core that go into the seafloor, and then the two other ships present here were just breaking the ice around, just to allow this. So it's a very heavy and costly operation to get record of the past. But it also means that we are limited in what we can understand for the past condition. This was an expedition in 2008, and it was one of the first expeditions that do northeast and northwest passage in the same time. In 2008, when we arrived in the northwest passage, there were no ice at all. It was super easy. We went through we were in advance of the schedule because it was so easy to go through. So it was really like, oh, we have plenty of time to do research. But again, you see, we are very, very limited to where we do research. So how that we connect that with shipping? We know that the decrease in sea ice, it's an opportunity for research. It's an opportunity for shipping. When we think about paleoclimate, it means we'll have access to areas that we don't have access. And this is great. But it also means that today we know very little about when this Arctic was free of ice. What was the condition? So there is a different time scale or pace between how fast the science will understand warm Arctic and how the shipping industry will use the Arctic or might use the Arctic. And this is where, and it's the reflection that all of the other speakers have had, we need to balance that because I want to say like the shipping industry will go into an unknown area about what will be the impact of their activities, what will be the changes. We know that the Arctic will change quicker than, we know that it's quick. We know it's probably quicker, but I cannot put numbers on that because we don't have the climate research to really help and constrain those numbers. And this is definitely, again, route that have been shown. This is, for me, from a scientific point of view, I think this is coming. I think the shipping industry will go there. Now, this will probably change very quickly. And as Adolf mentioned, probably the passage via the North Pole is probably the route that will be taken. But there is a lot of unknown from the science about potential impact and changes and how fast the change will happen. With that, I want to say thank you for your attention.